for the Ethiopian education.
Hello, teacher. Hello, students. Welcome to today's lesson on iron. The last time we spoke, we described the extraction of iron by a blast furnace. We learned that iron ore, coke, limestone, and hot air go into the blast furnace as raw materials. From those raw materials, pig iron, slag, and the waste gases, carbon monoxide, carbon dioxide, and nitrogen dioxide, are produced. In today's lesson, we are going to learn how pig iron is converted into steel. We will discuss the production of steel as well as some uses for it. We will also describe wrought iron. Let us get started. When pig iron is removed from a blast furnace, it has a relatively high carbon content. This makes it very hard and brittle. It contains about 2% silicon, 1% phosphorus and manganese, and some traces of sulfur, making it impure. Converting pig iron into steel is essentially a purification process in which the impurities are removed by oxidation. This process of purification is carried out in a furnace at high temperatures. There are 3 different methods that can be used to convert pig iron into steel. The Bessemer converter, the open hearth furnace, and the basic oxygen process. Students, let us discuss each of these methods. During the Bessemer converter method, pig iron from the blast furnace is put into a cylindrical vessel that contains a refractory lining of magnesium carbonate and calcium carbonate. Refractory means that the lining is able to remain strong, even at very high temperatures. A blast of hot air is blown through the molten metal from a set of small holes at the bottom of the vessel. The oxygen passing through the molten metal changes silicon, phosphorus, and sulfur into their oxides. These oxides then react with the lining to form a slag. The carbon in the pig iron is also oxidized into carbon monoxide, reducing its concentration. This whole process only takes about 15 minutes. However, the reaction is very hard to control. Therefore, the quality of the steel can vary. Let us move on to the open hearth furnace method. It uses a large, shallow hearth, which is usually lined with a basic oxide refractory of magnesium oxide and calcium oxide. The furnace is charged with a mixture of pig iron, ferric oxide, scrap iron, and limestone. Then, a blast of hot air and burning fuel is directed over the surface of the charge to keep it in a molten state. The impurities within the pig iron are oxidized by the ferric oxide and air. Carbon dioxide and sulfur dioxide are released out of the mixture as waste gases. The silicon dioxide and other acidic oxides, like phosphorus pentoxide, combine with the calcium oxide from the limestone and the refractory lining to form a slag. This is how the impurities in pig iron are oxidized. Calcium oxide, which is formed by the decomposition of limestone, reacts with oxides of silicon and phosphorus to form slag. The whole open hearth method takes about 10 hours to complete. However, it involves a reaction that is much easier to control. Therefore, the quality of steel produced is much more consistent. Also, a calculated amount of various elements can be added to the steel to form steel alloys with desired properties. Finally, we have the basic oxygen process. This is a newer method that, because of its high speed, has largely replaced the open hearth method. The process involves forcing a mixture of powdered calcium oxide and oxygen gas directly into the surface of the molten pig iron. The oxygen reacts exothermically with carbon, sulfur, silicon, phosphorus, and metals present as impurity metals. Carbon oxidizes to carbon dioxide. Sulfur oxidizes to sulfur dioxide, and both are released as exhaust gases. The oxides of silicon, phosphorus, and impurity metals combine with lime to form slag. The charge in the converter remains in the molten state by the energy that is released in these oxidation reactions. The converter is tilted to remove the slag, and after a second blow of oxygen, it is tilted once again, and the molten steel is poured out. The basic oxygen process only takes about 25 minutes. Students, let us do an activity. Please answer the following questions. What is the purpose of converting pig iron into steel? What are the 3 methods used to convert pig iron into steel?
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Welcome back, students. Pig iron is converted into steel because when it is initially taken from the blast furnace, it is hard and brittle. The three methods used to convert iron to steel are the Bessemer converter, the open hearth furnace, and the basic oxygen process. The purest form of commercial iron is wrought iron. The impure pig iron is heated with hematite and limestone in a furnace to increase the purity to 99.5%. This makes it a tough, bendable, and stretchable form of iron. Students, let us do another activity. Please write a list of 5 uses for steel.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Welcome back, students. There are many uses for steel that you might have thought of. You may have said that steel can be used for building things. Some tools and machinery are made of steel, and building supplies such as framing, siding, and roofing can also be made of steel. In today's lesson, we learned how pig iron is converted into steel, and we discussed some uses of steel. We also learned about wrought iron, which is the purest form of commercial iron available. This is all the time we have for our lesson today. Until next time, thank you, teacher. Thank you, students.